In this video, we'll be working through the question you see on the screen from the 2023 Ordinary Level Maths Leaving Cert. I recommend you try the question before watching, and if you get stuck anywhere, feel free to ask for help in the comments. I will do my best to get back to you. Check out my channel for a playlist with all the other questions. This is question 7 from paper 2, and this question mostly revolves around trigonometry. But the first couple of parts is a gradient question revolving around a road, where the road is from A to B here. They helpfully tell us, they remind us what gradient is. The gradient is BC, the height, the rise, over AC, the length, the run. Also, this is the slope, this is the derivative, and later on the question we'll see it's tangent. It's the tangent of an angle. Okay, to start us off though, they ask us a few questions about this shape, but the numbers are going to change every time. So I'll draw a new triangle down here every time. The first part 1, A part 1, they tell us that BC, this height here is 24, and AC is 135. Find the answer to the correct, to the nearest percentage. So find the gradient in percentage form. So that'll be the first thing that probably give people trouble. So find the gradient. They just tell us BC divided by AC. BC divided by AC. 24 divided by 135. And that's pretty much it. If you put that into a calculator, you get a few answers. Only the last one I write here is going to be correct. You get 8 over 45. That's usually okay as an answer. You get it in a decimal form, you get 0.1777, stay going on. That's usually okay as well, but they wanted it in a percentage form. So to get the full marks here, we need to change this into a percentage. Just multiply by 100, so it's 17.77 stays going on. And they wanted to round it off to the nearest percentage. So we'll say it's roughly 18%. So the gradient of this road is 18%. Okay, let's move on to part 2. We'll do a new triangle. So let me just rub out these numbers. So in part 2, they tell us the answer is 12%. They tell us the height is 16, and we don't know this number. So that's no problem. That's really what they're saying here is 16 divided by something is equal to 12%. A couple of things though, we don't write 12%, we write 0.16 divided by something is equal to 0.12. And we don't leave blanks here. It's not, you might have done that in junior cert, or sorry, in primary school even. But no, we don't leave blanks when dealing in maths. We put X's in, something you don't know. Put a letter, any letter really, whatever you want. We usually use X though. So we need to solve for X. So if we multiply both sides by X, we will get 16 is equal to 0.12x. If we divide, we need to get rid of this number now, leave x on its own. We divide both sides by this, we will get 16 divided by 0.12 is equal to x. And we put that into a calculator, we would get 133.3333 continuing on. And they wanted the nearest meter, so 133 meters. Okay, that's the answer to part 2. Let me clean some of this and we'll do part 3, 4 and 5. Okay, part 3, it tells us to use Pythagoras theorem when BC is 27, AB is 105, to find AC. So we want to find the bottom one here. So again, let's put in an X. We don't know it, let's put in an X. And Pythagoras theorem, the two shorter sides, so remember the hypotenuse is the long side. The two shorter sides, x squared plus 27 squared is equal to 105 squared. That's Pythagoras theorem. Short side squared plus the other short side squared is equal to the long side squared. That's all. We need to solve for x. Let's leave x where it is and move everything out of the way. So we get x squared is equal 105 squared. Take 27 squared away from both sides. 27 squared. We need to get x on its own, so to get rid of the squared we need to get the square root of both sides. Square root of 105 squared minus 27 squared.
put this in a calculator, take your time, do it slowly, do it in different parts if you need to, but put that into a calculator and we will get 101.4 something, 469 I think I say there. But they wanted it to the nearest whole number. Yes, there's whole number. So 101 meters. You don't have to put the meters in maths class. In physics class you would, but not in this. Okay, let's see if I can fit in number 4 down here. In number 4, they ask us to find the size of the angle when the gradient is equal to 9%. Okay, let me rub these numbers out here. So they're telling us the gradient, the answer is equal to 9%. What's the angle? What's this angle here? Okay, so this is the hardest one, I would say. Something divided by something. There's a really easy way to do this, sorry, but I'm going to do it the harder way first. Something divided by something is equal to 0.09. That's 9%. That's what they're telling us. X divided by y is equal to 0.09%. Now, I don't know what x and y is, but I do know I can write 0.09 as 9 divided by 100. So I do know 9 here and 100 here would work. I just don't know if it'd be the right triangle, but it doesn't really matter. If it's this triangle, 9 and 100, or if it's this small one, 9 and 100, or maybe even a smaller one again, 9 and 100. I don't really care if I've got the right length, because all I'm worried about is the angle down here. And the angle for these 3 triangles are the same. So I don't really care how long the road is. All I know is that the triangle 9 divided by 100 will give me the right angle. Because 9 divided by 100 is a 9% gradient. It's not the length of the road. Maybe the road is much longer than 100 distance or height of 9. Maybe it's much shorter. But the gradient will be the same. So I can go ahead and just solve this angle. So we have a right angle here. It's just a trigonometry question now. You could use sine, cosine or tan. So use your formulas. Which one would work? There's no h, so it has to be tan. So we get tan theta, the unknown angle here. Use any letter you want. Is equal to 9 over 100. Solve for theta or move the tan. So what destroys the tan? The inverse tan on both sides will work. So the inverse tan on both sides. And we just go ahead and put that into a calculator and we get theta is equal, one moment, theta is equal 5.14 something, and they ask us to the nearest degree. So the angle is 5 degrees. Okay, what was the fast way to do that question? When they told us that the gradient was equal to 9%, the fast way to do it is to know that the gradient is the same as the slope and it's the same as tan theta. You should think gradient, you should think slope, you should think derivative, but you should also think tan theta. It is just a gradient. So you should have been able to just start over here. You didn't have to think of x divided by y. You didn't have to think of different sized triangles. You could jump straight away to say gradient is 9%. Well then tan theta is 9%. Instead of percent, obviously 9 over 10. So this, you could have straight away just got tan theta is equal 0.09 and solve that and get the same answer. Okay, let me clean this off, and I don't think there is a fifth part. I added it up wrong earlier. We'll rub this off and go on to part B. Okay, in part B, they give us this triangle here, and they tell us a story. It's a girl, Olga, is somewhere here, or and P. She wants to know how far it is from or to P. Or to O, I'm sorry, and O is a really far, long distance away. So what she does is she measures some point P. She gets is it 20 meters? Yeah, 20 meters. She gets a long measuring tape or a piece of rope she's measured that's 20 meters long, and she measures off exactly this distance. And this is how you do this in real life. If you want to know how far away some building in the distance is, you can do the same thing as we're about to do here. So she measures off some distance, the longer the better, but about 20 meters is okay. And then she measures the angle from O, R and P, this angle in here. And that's easy enough to do as well. You could just use a protractor, even a small protractor. Bigger the better though. So let me draw that in roughly here. You know, protractor, semicircle. Put that on the ground, aim it to P, so the distance 20 meters away. Aim the straight bit, let me draw one again. Aim this straight bit along the ground to P, and then get your eye in close to the middle and look at the distance. Look at the object a long way away, in this case O, the building, and look at what angle it makes. So in this case it was 88 degrees. Do the same thing at this point, look at the angle, it's 87 degrees, and you get this sort of shape here. And with that we can now use maths to work out the length of OR. So we have a triangle with no right angle. So when you have a right angle, you should be thinking Pythagoras theorem, oh hell, another hour of algebra, that sine is equal to the opposite divided by hypotenuse, cosine, adjacent, and so on anyway. There's no right angle though, so you throw that out, throw that one out, throw that one out. They're the easiest ones to do. And what you're left with is two rules, the sine rule and the cosine rule. Personally, I think the sine rule is easier, so I try and make that work. I want to know this length, x. So what I need to do for the sine rule would be the length, x, divided by the angle across from sine of the angle across it, sine 87, is equal to another length, any other length you want, this is 20 we have, divided by the angle across from it. We're missing that one. So maybe we can't do the sine rule. Unless, can we figure out what this angle is? It's a triangle and we know the other two sides. It's 88 here, 87 here, and something adds up to make 180. So we're just missing 5. Double check that on a calculator, do it slowly, but we're 2 away from 90, we're 3 away from 90, so we must be 5 away from 180. So to finish the sine rule, sine 5 here. Okay, so the sine rule will work. We have an equation with only one thing we don't know. We know 20, we know sine 5, we know sine 87. So only one thing we don't know, x. Now again, you could use the cosine rule for this, and we will use that in part C. So you'll get to see how it works, but sine rule is a little easier, I find. Okay, let's fix this, rearrange this so x is on its own. I'll do it up here so I have room for part C here. We get x, multiply everything by sine 87. So on the left side it disappears, and on the right side we get sine 87 divided by sine 5. And that's it, x is equal to all of that. We can just go ahead and put that into a calculator. Yeah, here it is here. And we get x is equal to 229.15 something something something. And they wanted this to the nearest, meter. So that's 229. Rounded off to the nearest meter. So that's the answer to part B. And like I said, anyone can do this. You're not going to be, this answer is not exactly right if you do this, because remember you're very rough here. You're looking, the bigger protractor the better. I think a sextant is something you can use to do this better, but really a protractor works. The more accurate you are here, the more accurate this number will be. But in this case, I'll give you a good idea. So you can do it, your teacher's probably done this with you. Go pick something in the distance, a tree, a building, whatever, and you can work out the real length to it. Okay, on to part C. We have a new triangle here, so let me draw that. Something like that. And we have all the lengths, 700, 550, and 800. We've no angles. One thing you learn over the years doing trigonometry is to solve a triangle, to find out things on a triangle. Sorry, in this case, they want us to know this angle down here. What is this angle? To find out everything on a triangle, you need to know three things. Pretty much any three things. In this case, we know three sides. That's enough to solve it. The only exception is if you know three angles, that's not enough to get the lengths. But any other three things, one side, two angles, two sides, one angle, or three sides, you can now solve this. So just like before, there's no right angles, or we don't know if there is. So we can't use Pythagoras theorem or the sine, cosine and tan. So we need to use the sine rule or the cosine rule. So you could try the sine rule again. A side we have divided by the angle across from it, so 550 divided by sine theta, that's fine, is equal to 800 divided by, oh, we don't know this angle. So that's used, we don't know this and this. Can't do an equation with two unknowns. So the sine rule is out. But we still have the cosine rule. Let me write the cosine rule here. It's in your formula table. It's a squared is equal to b squared plus c squared minus 2bc cosine theta. Let me get a box around that. That's a cosine rule. Basically, it talks about side, a side, a side. The same two sides, B and C, are already here. So the three sides are used and one angle. And that's good because we know three sides and we want to know one angle. So this is the good rule for us. So let's just fill this out. We need the angle, sorry, instead of theta, it's usually A, big A. This side and this angle, they're matching. So if this is little a, this is big A. They're the ones across from each other. So write this out again. We pick one of the sides. Again, it has to be the one across from the angle we want. So we have 550 squared is equal 700 squared plus 800 squared minus 2 times 700 multiplied by 800 multiplied by cosine of theta. Let's look at this equation. There's only one thing we don't know, theta. So we can do this one. We just have to rearrange it so theta is on its own. So it's going to take a few minutes. This is why the cosine rule is a lot harder. First thing we do, let's move these two guys. Let's take them away from both sides. And we will get 550 squared minus 700 minus 800. So we took these two from both sides is equal minus 2 times 700 times 800 times cosine theta. Okay, next thing we can, this number here, 2 times 7 times 800, you can do it on a calculator, but it's really just one big number and it's multiplying by cosine. So let's divide both sides by it. So let me just save myself room and I'll put it here, minus 2 times 700 times 800 and divide this side and that cancels. So we're left with cosine theta is equal to this. Now we just need to get rid of the cosine theta. To get rid of that, we get the inverse cosine of both sides. I ran out of room a little here, apologies for that. Inverse cosine of this side, inverse cosine of that side, and we're left with theta equals this big mess. You need to be really careful putting this into your calculator. You can do different parts separately. Write it all down, show the examiner what you're doing. If you're really good at a calculator though, you should be able to put all of this in one go. But really take your time, be careful, do it multiple times, make sure your answer looks reasonable. Something between 0 and 180 first of all. But if you put this into the calculator carefully, you will get theta is equal to 42.367 something something something, and they wanted that rounded off to one decimal place. So that is roughly equal to 42.4. This rounds off to 42.4. Okay, I hope that answered all your questions. Remember, this is a part C. It's meant to be a bit awkward and messy. Cosine rule always is. But if you have any other questions, please put them in the comments below and I'll do my best to get back to you. Have a great day and I'll see you next time.